Hi class, section R5, factoring polynomials. This is part 2, factor by grouping and factoring trinomials with a leading coefficient of 1. Okay, so we'll start with factoring by grouping. In this first example, you'll notice that a plus 3 is common to both of these two terms. So a plus 3 gets factored out. In the first term, we're left with an x, and in the second guy, a minus 4. So inside these second parentheses, we have x minus 4. Okay, for part B down here, this time we're given 4 terms, okay, and we want to first look at all 4 of them. Is there anything we can take out of all 4? And the answer is no. So then we're going to try to factor it by grouping, which means we group the first 2 together, group the second 2 together, and then factor. Okay, so for the first 2 terms, an x can be taken out, and then we're left with y minus 2. For the second 2 terms, this 5x minus 10, I'm going to take out a positive 5, and then I'm left with y minus 2. Okay, so now the problem looks more like that first one that we just did. So you'll notice that y minus 2 is common to both, okay? If these guys don't have anything in common, then either you're not able to factor by grouping or you made a mistake and go back to the beginning and start again. Okay, so the y minus 2 is what these guys have in common, so we factor out y minus 2, and we're left with x plus 5. You could FOIL this to make sure that you get back to the beginning. Okay, that's one way to check your answer. Okay, part C, again, we have 4 terms. Looking at all 4 of them, there's nothing that they have in common. So I will factor by grouping. I'm going to group the first 2 guys together. They have an x squared in common, so take out the x squared. And I'm left with y minus 2. That's a coincidence. And then the last 2, negative 3y plus 6. Okay, this time I'm going to take out a negative 3 because I know that in the parentheses here I want to come up with a positive y minus 2. So I factored out the negative along with the 3. Okay, so the y minus 2's match up. I'm taking out y minus 2, and then we're left with x squared minus 3. Okay, so a couple things I want to mention. When you get to that second set of terms and you factor it out, you're either taking out the positive version of the number or the negative version of the number. So please make sure that you're either writing a plus or a minus here. If you don't write the plus or minus symbol, then it's really multiplication, right? So if I rewrite this the wrong way and don't put in that minus, this expression down here is different than what I intend, okay? Because this really means just multiply those 4 things together. Okay, so make sure that you're putting in that symbol plus or minus. Okay, good. Next, factoring a trinomial of the form x squared plus bx plus c. So a quadratic trinomial is a trinomial of the form ax squared plus bx plus c, where a and b are non-zero coefficients and c is a non-zero constant. So in this video, we're assuming that a is the number 1, and that actually makes it easier to factor, as we'll see. Okay, so the factored form of our trinomial is going to look like x plus something times x plus something else. Okay, so I'm using an m and n since we don't know what those numbers are yet. Okay, so let's say we FOIL this. So I'm going to distribute the x and distribute the m. So I'll come up with this expression here, x squared plus x times n plus x times m plus m times n. Okay, in the middle, these guys are like terms. They both have an x. So I can essentially factor out the x, okay, and write m plus n times x there in the middle. Okay, so notice that what I have here on the right matches up with my x squared plus bx plus c. Okay, so b, that coefficient in the middle, must be m plus n, and c, my constant at the end, has to be m times n. Okay, this means that I'm looking for 2 numbers or 2 integers, m and n, such that they add to be the middle coefficient and they multiply to be the constant. Okay, so let's practice this a few times. There are many different ways to show work in these problems. One way is to just make this big X here. This is how I will do it, but as long as you have some way to factor, it doesn't have to be this method here. Okay, for the first one, we're looking for two numbers that multiply to be 15. So I'm going to put 15 at the top and add to be 8. So I'm putting 8 there at the bottom. Okay, one trick to remember here, A times C over B. So air conditioning over the basement. That might help. Our A in this case, for all these problems, our A is the number 1. So we have 1 times 15, so that's 15. That's my A times C over the basement over B, which is 8. Okay, so what are two numbers that multiply to be 15 and add to be 8? Well, 5 times 3 is 15, and those numbers add to be 8. Okay, these problems are what I sometimes call the happy face problems because they factor super quick. Okay, once you get those numbers, 5 and 3, you're done. You just plug them in. X plus 5 times x plus 3, and that is factored form for x squared plus 8x plus 15. Okay, part B, and I'll put my x over here. Part B, we want two numbers that multiply to be A times C, so 1 times 54, which is 54, add to be negative 15. So make sure that you're including positive or negative symbols when they apply. Okay, so let's see, what multiplies to be 54 and adds to be negative 15. I'm just going to write it over here for now. So we know that 9 times 6 will give us 54. And then when I add those together, I do get, in this case, I would get positive 15, right, if I just add those two positive versions. But if I make them both negative, negative 9 and negative 6, they still multiply to be positive 54, but now they're adding to be negative 15. Okay, so now go back to your trinomial, and again, happy face problem. So once we get those numbers, we just write them in. X minus 9 times x minus 6, and we're done. Okay, part C, we want to be careful. Okay, the leading coefficient in this problem is not the number 1, it's a 3. Okay, but I notice that 3 divides into all three of my terms. So I'm going to factor out a 3 in the first step. So I have 3 times x squared minus 4x minus 12. Okay, and now inside the parentheses here, I'm going to factor this trinomial. A times C is 1 times negative 12, so that's negative 12, and the numbers need to add to be a negative 4. Okay, good. Let's see, 6 times 2 will multiply to be 12. If I make the 6 negative, they'll multiply to be negative 12, and I chose the 6 to be negative. This way they would add, the two numbers add to be negative 4. Okay, good. Still, it's a happy face problem, right? Easy to factor. This 3 just carries through in our answer. So 3 times x minus 6 times x plus 2. Good. Okay, a few more. X squared plus 5x minus 1. So let's see, I'm looking for two numbers that multiply to be negative 1 and add to be 5. Well, nothing does that, right? Nothing multiplies to be negative 1 and adds to be 5. So notice the directions they factor if possible. Okay, part D, you were just right. You could write not possible. You could write non-factorable. Or you could write prime. Either one of those is acceptable. Okay, we were asked to factor the expression, and it's not possible to factor. Okay, so any of those three answers work. Okay, moving on to part E. This time we want two numbers that multiply to be 144 and add to be 24. Okay, so 12 times 12 multiplies to be 144 and they add to be 24. So for part E, I can write my answer as x plus 12 times x plus 12, or I could write my answer as x plus 12 quantity squared. Either one's okay. All right, and then finally part F here. Again, I see that I don't have a 1 as my leading coefficient, so I'd like to try to factor out the 3, and it works, right? 3 goes into 15 and 18 as well. So I'm going to take out the 3. And then also I'll take out an x squared since that's in all 3 of those terms. I'm left with x squared minus 5x plus 6. Okay, so now I'm ready to factor my trinomial. I'm looking for two numbers that multiply to be 6 and add to be negative 5. Okay, so let's see, 2 times 3 multiplies to be 6, and then also 6 times 1 multiplies to be 6. I want them to add to be negative 5, so the correct answer is negative 2 and negative 3. This way the numbers multiply to be a positive 6 and add to be a negative 5. A common incorrect answer for this problem would be to use a negative 6 and a positive 1, since these numbers add to be negative 5, but be careful, when you multiply them together you get negative 6, so that's why you need to be careful about the signs, whether it's positive 6, negative 6, okay? There's only going to be one correct combination of numbers, but there might be a second pair of numbers that's close, so just off by a plus or minus symbol. Okay, so we just need to be careful. All right, so again, back to our solution. So 3x squared remains as part of our answer. Multiply this by x minus 2 times x minus 3. So that is factored form for part F. Example 3, you're going to complete these and turn them in through Canvas. So factor, if possible, G, H, and I. Good luck. Let me know if you have any questions.